Hello, everybody. Josh Carloni, New Hampshire Fish and Game. Today I'm going to be talking to you about the influence that temperature, activity, and abundance has on catching traditional ventless traps, as well as some early benthic phase traps we've been experimenting with. And goes without saying, this was a group effort. Everybody here put in a lot to this project. So as I said, first, one of our main objectives was to develop a trap to catch traps not caught in other surveys like the Ventless Trap Survey and the Trawl Survey. And those are animals kind of in the 20 to 50 range. And then what I'm going to be focusing on, what I'm going to be focusing on more today is assessing the influence that these factors have on ventless trap catch primarily. We'll get into a little bit of the early benthic phase design and stuff like that, but primarily I'm going to be talking about ventless pods. So most of you know this, but for those of you who don't, the Ventless Trap Survey is conducted from Maine to Rhode Island. It's conducted June to August, and it's a random depth stratified survey, and questions remain. The survey is a robust survey. It gives us an index of abundance, but we still do have some questions as to the influence of some of these factors on eventual catch. And so just quickly, this is the early benthic phase trap that we used. It's designed after a crawfish trap in the Midwest. Steve Jury used to fish these in the late 90s. And basically, whoops, I keep doing that wrong one. Basically, what you have is you have an entrance here, and then there's an entrance on all four sides. These are basically parlors, and we modified the original design a bit to put some heads in there. So lobsters are retained in really any one of those four parlors. So our sampling design was, we sampled these 6 sites along the coast of New Hampshire. We basically wanted hard substrate with rocks that you can turn for this survey. We wanted all of these sites to be as consistent as possible. So we did extensive dive surveys, and we also did some drop cam work. And so these were the 6 sites that we settled on. There's 3 deep and 3 shallow. The 3 deep are about 20 meters, and the shallow is about 8 meters. And one of the main reasons for that was we wanted to assess a variety of temperatures during this research. So what we did was we did a scuba survey, and this was transect lines. We did at least 3 10-meter transect lines at each one of these sites. And then, so we had our abundance estimates from that, and we followed that up with setting traps. And what we did was we had 4 traps at each site, 2 early benthic phase, 2 ventless. Again, I'm going to primarily focus on the ventless today, but the idea was, again, to set at all of these sites and look at the effect that these factors have on catch. I do want to point out the design was a little interesting in that we did April, June, and August. And the reason for that is we wanted to set these traps in April before water temperatures started to warm up. You have really cold. June is kind of a transition period, and then August, you have those summer-like temperatures. And we wanted to collect some additional information too. So not only did we have this is the transect line, and we were catching abundance, doing the abundance survey there. We also did additional habitat work. And then we also put these little accelerometers on lobsters, and we deployed those in what we called activity cages. And we did this before, as we were setting traps. So we would go out, deploy these, set the traps. And the idea there is you want to see what the activity is while those traps are fishing. And we did that in every month so you could get that idea of how that changed seasonally. And then lastly, we put current and temperature monitors on here. The current meters, I do not go into anything on that today, but we are going to analyze that in the future. And so the idea is, how do all of these factors go into what you see in that trap coming up? So the first thing we wanted to do is just throw all this into a correlation matrix and see what comes back as significant just as a first step, and then dive deeper into some of those factors. And the two that came back as significant were catch and activity. Interestingly, abundance, what we found on the bottom, did not seem to be driving what was coming up in the traps. And I'll get into that a little bit more in a minute. And just more on that abundance is what you have here is abundance on the side from the scuba survey, and then you have the month on the x-axis, and you can see throughout time, throughout the season, there was not a trend in abundance. Not really what I expected, because I expected as water temperatures warmed, the abundance would increase, your estimates would go up. There could be something where they're moving into different habitats for sure. So what was the relationship between temperature and activity? So on the y-axis, you have activity, which is the proportion of each hour that they're moving. And then on the y-axis, or sorry, the x, you have temperature. And what you see here is at lower temperatures, you have lower activity. As it increases to a certain point, but then it kind of plateaus. Again, there's a lot of variability in here. This was from animals deployed in the field, so you have a lot of other factors going on, but that was the general trend. And for those of you who have followed kind of this activity temperature thing, this should look familiar, because McLeese 1958, which is kind of the gold standard for this, shows a pretty similar thing where you have this increase in increase in activity to about 10 degrees, and then from 10 to 20, it kind of plateaus. So that was kind of reassuring to see that. But what about activity and ventless trap catch? Well, it was pretty similar to what I just showed you. So at low activity levels, you have low catch. As it increases to moderate, you have kind of moderate catch, but then it never increases again. It kind of plateaus. But what about temperature? Things look a little bit different with temperature. So what you see is at these low temps, you have low catch. Then in this moderate level from 10 to about 15, you have kind of moderate levels of catch. But then you have another spike in catch with higher temperatures. That's informed by a few data points. So take that with what it is. We're in the field, we're in situ, we can't control the temperatures. This is just the data that we have. So the next step was to throw all this into a generalized linear model and see what comes back as significant. And what came back as significant, as you may have guessed from that last plot with temperature, was temperature. And so this profiler plot, I think, describes that pretty well. Let's give this a try. So on the y-axis, you have your catch, and then you have your factors at each one of those. And what this does in JUMP is it allows you to choose kind of a temperature, and then it shows you kind of what the other factors are. So those crosshairs there, if we choose 17 degrees, if you go over to activity, it's kind of in the moderate levels. And then if you go over to abundance, that too is kind of in the moderate levels, kind of describing that temperature really seems to be driving the catch. So this got us to thinking, well, what else is temperature acting on? Well, we know it's acting on metabolism and likely hunger. So how motivated these lobsters are to go into a trap as temperature increases. So we followed this up with a lab study. And what we had was an 80-gallon tank. I wish I'd taken a picture with actual lobsters in there, but I did not. But basically, we partitioned this tank into 3 sections, and we had 3 treatments. So we ran it at 6, 10, 14, and 18 degrees. And what we did was we presented each lobster, so 3 lobsters, we presented them with 5.5 grams of squid every hour from 9 to 2 p.m. And if they ate it, then we would put another piece in. If they didn't, then we would leave it. At the end of the day, you would measure how much each lobster ate, and then you get an idea of what they ate at each temperature. And we gave about 3 days before each feeding, and then we did 3 of these trials. And this is what we found. So if I can draw your eye to this plot, you can see at 6 degrees, they did not feed that much, although they did feed. You go to 10, they ate more, and then you have a big jump to 14 and a big jump to 18. This is pretty consistent with Wang et al. Paper, where they fed them mussels. So that was good to see. They didn't go to the 18-degree mark, but they did go to 15. And so you have a significant difference between 6 and 14, significant difference between 6 and 18. And then kind of what we were looking for was, is there a difference between 10 and 18? And we did find in this case that there was a significant difference. If you think about it, like activity doesn't change much between 10 and 18, but the amount they're feeding and probably their drive to enter a trap definitely does change. Just quickly, I'm going to go into the early benthic phase traps. So I already described what they look like. Here is the length frequency distribution compared to the ventless trap survey. And you can see that they are catching smaller animals. Really, it's this 40 and below that I think we would be interested in. The ventless trap survey does not really catch those. The mean size for these guys is about 48, 70 millimeters for the ventless trap survey. So the trap seems to be working. I'll talk about a couple of issues we had. And so the other thing we wanted to see, obviously, is does this correlate with what's coming up in the ventless trap survey? So we basically just did a correlation analysis to see seasonally if these two are correlating. And as you can see, it's a pretty strong correlation between the two, suggesting that those seasonal catches are similar. They're picking up on the same signal, which was reassuring. And then we put that same, we put the catch from the early benthic phase traps into the GLM just to see what came back as significant. And again, temperature seemed to be what was driving the catch in that. We did have, and I wish I had a picture of it, issue with cunner bycatch. In some areas, we would catch a ton of cunner. Jason can attest to this because it was not fun picking cunner out of a trap. We ended up sometimes just dumping them. It didn't seem to influence the catch of lobsters, but we're doing some follow-up predation analysis with cunner and lobsters. And I do think anything under 20 millimeters probably would get gobbled up. And we're also experimenting with these traps out on George's Bank. So we'll have something to present on that at some point. So to wrap things up, we found that abundance on the bottom did not seem to be the main driver of what was coming up in these traps. Temperature best described what was coming up in them. I know this brings up questions like, what does this mean for the ventless trap survey? I don't think the ventless trap survey is not looking at those seasonal changes. It's looking at an annual index. So you're comparing one year to the next. So I think we're, at least from these results, we're probably good there, but I do think it might be useful to look at, if you took that survey and you just looked at catch from 10 to 15 degrees over the time series to see if that looks any different than just putting it all together type of thing. But there's more to think about there. The early benthic phase traps seem to be tracking a similar signal as the ventless pots. And the best utility for these early benthic phase pots might be offshore where, we don't know a lot about recruitment. Collectors are not fun to work with, as Eric has pointed out. And these may be a good option because you know that a lobster that was like 40 millimeters didn't walk out to George's Bank. So, and I think that's it. Thank you to, should have mentioned this to begin with. This is ALI funded Sea Grant. So thank you very much.
Does anyone have any questions?
Thanks, Josh. This is really exciting, and I really like the trap design. It's really interesting to get at the smaller sizes. I have a question about the experimental design for your lab setup.
Yeah.
So can you just clarify, you had one tank that you had 3 lobsters in, and you did your experiment. Did you use the same 3 lobsters for all 3 trials, or the same 3 at each temperature, or were they 9 unique animals?
Sorry. We used the same 3 lobsters for those, the treatment. So we did 6, 10, 14, and 18 with the same lobster. But then when we ran it again, we switched out the lobsters and ran it again.
But all in one tank?
All in one tank with a good period of time between. Yeah.
Okay. Thank you.
But just to clarify, so the tank is an 80-gallon tank. We split it into 3 sections, 3 lobsters at a time.
Right.
We did all the treatments, and then we did it again 2 other times past that.
Thank you.
Thanks, Josh. Super cool to see this work. For the temperatures that you're correlating with the field experiments,
Yeah.
are you just using the temperature the day that you caught it, or are you thinking about like the average temperature over like the week before?
Yeah, so I should have also mentioned, this is still pretty preliminary. So, you know, we're getting to a point where we can hopefully publish this soon, but there's questions like that we've thought about for sure. What I believe we did, and I did most of this analysis back in January, but I think what I ended up on was taking an average temperature for the period of time those traps were set. But it does bring into, does that temperature before matter? So there are some things we could do with that to test to see if that makes any difference.
I'd love to talk to you more about that.
Yeah.
Thanks so much for the talk. So you mentioned that you think a lot of in the early Bentley phase traps, a lot of the small lobsters under about 25 millimeters are being eaten up by cunners. Why do you think they're getting into the traps at all and maybe not like entering them in the first place? Like, do you have a reason to think that they're getting in there and being eaten?
I think the answer to that is, A, we don't know. We didn't see any evidence, particularly in those traps, of predation. My guess is that anything under 20 millimeters, as I said, we kind of have been doing a follow-up study with predation, and our preliminary results suggest that cunner can predate on a lobster up to about 20 millimeters. After that, they seem totally fine. Like, so I think from 20 to 40, and it matters the size, but I think like 20 to 40 millimeters, these guys are totally fine around cunner, but they're super vulnerable. I mean, it's been shown that PLs, when they settle, they'll get gobbled up. That work has been done. To my knowledge, nothing's been done over kind of just settled post-larval stage. So we are looking at that, but I don't think they're entering the traps.
That's kind of what I would expect too, considering a lot of the small ones like to stay in shelters in their early life history.
Yeah, exactly.
Yeah, I was curious maybe if they were entering them in the first place or if you thought more of them were just being eaten by cunner.
I probably think they're not entering, but that was the idea, to have 4 entrances so that maybe if the trap's near a shelter, they're going to be more apt to go into it. But my gut tells me those real small ones aren't going far and not entering the trap.
Fair. Thanks so much.
Yep.
Anyone else?
Hey, Josh, nice talk. Although I missed part of it, sorry about that. But I was just picking up on the last part of this conversation. And it sounds like you're seeing a similar pattern to what we're seeing with the collectors, you know, that we're missing this size segment that's post-settlement. So we get a strong settlement signal of really small, young of year, you know, 8 to 10, 12 millimeter carapace length lobsters. And then we're missing like up to about 25 millimeters. And then you get a whole slug of what we call walk-ins, you know, they're migrating in along the bottom. So that sounds really similar to what you're seeing, just the smallest ones, or the smaller early benthic phase lobsters, just not having a propensity to move around. But with the collectors, we get that settlement signal too that you may not be seeing with your traps.
Yeah, that's interesting. I think like it's 20 millimeters is when we start seeing them in the trap, but it's really kind of 25 where we really start seeing them. So yeah, I don't know. That's a bit of a mystery. So
Thanks.
yeah.
Anyone else? No? One more.
So at the end, you mentioned putting the early benthic phase traps into deeper water. Have you thought about putting them in shallow water as well? Because I use cameras for my research, underwater, like beta remote underwater cameras, and we put them about 20 feet of water last year during some pilot work, and weren't really seeing a lot of juveniles. But when I cut the height in half this year, I was seeing a lot more juveniles and about waist deep water. So I was curious if you thought about maybe deploying them in shallower water and seeing like what the differences could be, maybe.
Yeah, so we did, and maybe I wasn't clear, but we did, as part of the design, we did deploy them in it's like 20, 25 feet of water. So that was part of the design that we fished them. Are you suggesting going even shallower than even? We can test that out. It's a good idea. I mean, it would be nice, particularly in New Hampshire, you can get up into some really shallow areas with nice cobble that you can turn. Yeah, so I think that would be something worth trying for sure. Yeah, yep.
Great. Well, thank you.